Okay, welcome to a new week. All right, so this week it's about loops, and yes, I am familiar that you have obviously seen loops before in 1101. However, I don't know if you've seen the loop interrupters. That'll be maybe something new for the day's class, maybe not. And I do promise, like next class will be something different because I know you don't cover for loops in the other course. All right, so at least something new this week. Okay, so yeah, the review stuff is slowly disappearing. Hopefully it's still proving to be somewhat beneficial, even if we are reviewing things. Hopefully I hit a few things that maybe you didn't know about before. All right, first thing up, sorry, I know why this is here. I was like, why did I open this one up top? It was to cover this one right here, and that is I am obliged to take a few seconds and point out that we now have a syllabus. Okay, so sorry this is taking a little longer than it should have. Let me just do a quick little coverage of what's in the syllabus so that you understand how to read it. All right, so first of all, yeah, there's a description about what the course is doing. That's not really a big deal. I've said before my office hours will be listed here, but generally, here's the deal is Sunday, Monday, Tuesday's not bad. Wednesday, Thursday, stay away. Okay, I'm not trying to be nasty. There's absolutely no time. So that's my preferred days: Sunday, Monday, Tuesday. Even though I don't list a Tuesday, yeah, basically if I'm there, it's okay. I can usually entertain something unless I'm really, really freaked out and stressed by something. I might say come back in a little while. All right, so all of that stuff is there. I can't remember if I've ever warned you about the textbook, but the official textbook of this course is really good. No, if you're listening to this online, do not read the book. You'll probably be more confused than any clarity. Find any other textbook except that one. That's my opinion of it. The one that I provided in D2L from the OpenStax, it's not bad. It's a little bit limiting, but you're going to find lots of other books. All right, but in any case, yeah, the usual thing, yeah, we've got a whole bunch of learning outcomes. Basically, here we go. This is what we're planning to do in the courses. We're going to cover something called fundamental concepts of procedural programming, which means, well, all of the stuff we've done so far, so basic logic, if in branches, functions. Okay, that's what procedural programming means. Implement programs using non-primitive data structures. Okay, so yeah, we've learned about data structures called ints and floats and strings. We're going to, in this course, learn about things called lists and dictionaries and sets and tuples. Challenging, but really, really important, by the way, for anything to do with programming. We will cover some basic searching and sorting. It's something we do it takes like about a week or so towards the end. Don't worry, it's not really complicated stuff. And we'll also do some I/O programming, including like reading and writing from files, because I think it's really important. Okay, that's the overall topics. Now, next thing up is, yes, there is a weekly outline, so let me explain what you'll find in the weekly outline, other than, obviously, the weekly outline. All right, so you'll notice that we've got the weeks listed down the left-hand side. I always make sure to include the dates so you know exactly which week we're talking about. And surprise, surprise, we're in week number 3, January 18th to 22. So if another course tells you they're in week 2, I don't know whatever week they're in, but we're in week 3. Now the dates are here, so we know. What will we be doing? Okay, the first column I always use to indicate these are the materials we're going to cover in the lecture. Like, for example, we're covering loops. Oh, good. And next class we'll cover for loops. Next class, next week, we'll be covering functions, then variable scope. You should be able to figure out exactly what set of slides go with this because I use the names to match. Okay, so if for some reason you can't come, you don't need to ask what am I missing because you already know the answer. Okay, so if you do miss a lecture, these are the things, and of course, well, you know, you will find recordings as long as I remember to hit record, which I am. All right, the furthest right-hand column, it's called activities, but what I do is I include everything where an assessment is going to be happening. Okay, like for example, this week, you apparently are going to be working on Module 2, decisions. The good news is those modules don't count for anything. You'll also be doing Lab 1. Okay, yeah, there we go, SS announced already. Next week, you will be doing Module 3, which doesn't count, but you'll also be doing Quiz 1. Okay, yeah, okay, so those are the evaluations. Normally what I used to do is I used to color the ones that were important as being red. But I'm told I'm not allowed to use colors on my syllabuses anymore, so I can't do it. But you'll notice what I can do is I stuck a little star on some of them. Okay, what the stars mean is this is just for practice and it doesn't count. Ah, good. So lab 1 this week doesn't count. Yes, good. Do it like it's an actual lab. The instructor should give you a grade for it. The instructor should provide you some feedback on what you've done right, what you've done wrong, but it doesn't count in the grade book. Okay, so basically, we measure lab number 2, lab number 3, lab number 4, then lab number 6. I thought 4 of them were good enough. I don't want to overstress people by having too many of these evaluations. So there are 4 of them we pick. Sometimes we pick different ones. These are the ones I picked this semester. All right, so you know exactly what's coming in advance before each week, so you can say, okay, you know what, I'm going to have to practice for a quiz 1. Now, what's missing is I've never included a description about the types of things. I will provide that in a news item so you know exactly what's coming. All right, now, unfortunately, we've got a couple of the big assessments. So you'll notice here in week number 8, February 22nd to 26th, you'll see this word right here, midterm, and it says February 21st, and I put SAT, okay, which is unfortunately, as I've said before, I have no choice. I have to bring you in on Saturday because there's just too many students. I wish I could do this during the labs, but it's impossible for me to make 20 different exams for the midterm and have them all the same level of difficulty. Okay, it's really, really tough. Actually, I would say it's impossible. Even courses where I've got to do 4 or 5 of them, it's really, really tough. So unfortunately, it becomes a Saturday. This is not a confirmed date yet, but I hope it's going to be there. What I need to do is I need to put in a request saying I need the following rooms for this day, and they'll come back and they'll say, okay, they're available at this time. Okay, as soon as I get it, I will let you know. Usually by the 3rd or 4th week, I have this sorted out. So by next week, it should be done. All right, so we do have this one, so sorry about that. All right, next one up. I actually just realized that I made a mistake right here because this week has Sports Day stuck right in the middle, right? Yeah, and I realized that I've got a quiz 2 set aside and it doesn't have a star. Okay, don't worry, if you happen to be impacted by that, I'll make sure it's very, very clear what you're going to do. Okay, so I will tell the instructor, this is what you're going to do. Basically, you move quiz 2 to the next week, which unfortunately means you probably do 2 of them, but it's only for the sections affected. Okay, so I will make sure that's very, very clear when we reach that week. You'll also notice, of course, that I've got this Eid al-Fitr question mark. Yeah, well, you know how this works here. We don't really know for sure which days we're getting. And exactly which days we get might have big impacts on things. So here's what's going to happen. As soon as that holiday has an actual date set to it, I'll have to update this schedule, and I will let you know that the schedule is being updated so you know exactly what's going. Okay, so as soon as I know this, I will push it. It's very rare that I would move something sooner. I am more inclined to push it later or get rid of it completely. Okay, so you can always look forward to that. I will never add extra things to it. Like, for example, there won't be quiz 6. No matter what happens. Even if they cancel Eid, no, there will not be 6 quizzes because I said there's only 5. However, what I might do is maybe I let quiz 5 not count or just throw it out or something. That's to be decided later when I need to get to this, okay? I'll make sure that you know plenty of time in advance. All right, the next one is you will see yet again, there's another Saturday sitting. That's the lab exam. That's the heavy programming side. Yeah, we make you do programming in the midterm. I'll announce all of this when we get there. But that is just straight out programming, no MCQs. It's also 2 weeks, but it's also the same thing. It has to be a Saturday because I have to make sure everybody gets the same questions. Otherwise, we have some issues. All right, so there we go. Those are the big things. And then, of course, the final exam at the end. All right, the most important one that everybody always wants to know is what's the grading scheme. Okay, there's the grading scheme. The final exam is pretty big at 35%. I know that's bigger than some courses, but this is what I have to work with. The midterm is worth 20%. The lab exam, which is sitting down here, is also worth the 20%. So, yeah, the individual assessments are pretty big. The quizzes are those small MCQ things that you'll see in the labs. There will be 5 of them, so 3% each. And the labs, well, I'm hoping that I'll have 4 of them, so they should be 2.5% each. Okay, I have no problems getting 4 labs in place. Okay, so there we go. That's the syllabus. It is here. If I have to make any changes to it, I will put up a new version and I will post an announcement in the news section to say this is what changed and this is why. My first expected change has to do with Eid. The second thing I will post as soon as I have a guarantee of the dates for the lab exam and the midterm once I get some rooms confirmed. Okay, so I apologize. Normally this should be done in the first week, but because of some processes, things took a little bit longer. All right, so here we go. On to something new. It's not supposed to be new. Okay, so is different? Well, maybe different, but it shouldn't be new. These things, I believe, are all covered in INFSC 1101, but again, I like to repeat them because these are types of things that we will see all the way through. Like, for example, if somebody says, oh, I hope you don't have loops. Guess what? We're going to have a lot of loops. Everything we do is loops. All right, so we're talking while loops. This is the one we're dealing with today. Here's a reminder of the assessment. I just did that, so that's not a problem. All right, so why do we have loops? Because they're really difficult? No, that's not why we put them. They are difficult. And the reason why they're difficult is because you're talking about doing a piece of code over and over again where the code stays the same, but the values change each time. That's actually what makes loops difficult, because you need to look for patterns. If you're somebody who struggles creating patterns or observing patterns, you will find looping to be very difficult. Okay, so this is the problem solving that comes from 1101. All right, so I'm not going to cover a whole lot of time on this. What I really want to do is to get over so we can start running some code, because it'll make a whole lot more sense. All right, so first thing up is, yes, for loops, we have a couple of different styles of loops. The one that I will probably use for the next couple of days is going to be this one right here. It's called a while loop. And I know that this loop is something that's used all the time back in the 1101. So, hey, I thought this would be a good place to start. All right, so a couple of important things about the while loop that I've put up here. Okay, first of all, you can tell it's a while loop because it's got the word while. Okay, and that's pretty obvious. All right, and you can see that inside a while loop, I always have something that's called the body. In fact, if I show you the typical picture, you saw it a few minutes ago down the right-hand corner, you'll always see the same picture show up in 1101. You see it show up here a couple of times, where you enter a loop, you go into some kind of a test expression where you find out whether or not the condition is true. You either perform the body or you exit the loop. Okay, so the body, of course, is the stuff that I just highlighted, and of course the really important thing is, how do I know that that's all inside the loop body? Has to do with indentation. Okay, so for right now, this is not a trick question. How many lines of code are inside the loop body? 3. Okay, very good. All right, and okay, let's try it without. Hello. Okay, just give me a second. I'll make that go away. Good, that should be gone now. All right, and okay, maybe I typed the right thing. All right, so now a question: how many items or how many lines are in the loop body? Yeah, there's only 2. So remember, it's only the stuff that's being indented. Okay, and since we're here, okay, that should be pretty obvious. How many lines? 1. Good. Okay, and right here, how many lines are inside the loop body? Only 1. All right, that's only 1. However, if I try to run this program, what's going to happen? Why? Why is it an error? Unexpected indent. On which line number? Oh, I hear 4 and I hear 5. It's line number 5. That's the unexpected indent. Okay. Line 4 is not an unexpected unindent, which means to not indent something. Okay, but line number 5 should not be indented, because there's no if, there's no loop, there's no body required anywhere. Yes.
Wasn't it supposed to print start of loop and row?
Oh, okay. So here's an interesting thing. Okay, that's cool to ask this. So the question is, how come it didn't print start of loop body? Well, okay, so remember, so this means that absolutely nothing happened. So what type of error is this? Is it a runtime error or syntax error?
Syntax.
It's a syntax error. That actually prevents the entire thing from even starting. Okay, it's so bad that Python just said, yeah, I'm not even going to try running this. All right, so that's pretty cool. Okay, since we're here, let's do this. Exactly the same thing. Yeah, but it's only a space. It doesn't matter if it's only a space or not. It still is an unexpected indent. That is because when you cut down to dealing with indentation, okay, here we go. When you're dealing with indentation, that is permitted. Okay, I don't think it's a very good idea. In fact, almost everybody says this is a really bad idea. Once I find my cursor, clear the output, and we'll run it. Of course, now it's working because there is no syntax error. Okay? All right, so that's fine, though. So there's no syntax error. How come I don't like it? I mean, this is kind of a personal preference, but I'm going to push my personal preference onto all my students, too, because it's really good practice. Why do you think I don't like a single space? It's not clear. The issue is that when you work on big programs, you're going to end up with several levels of indentation. You're going to have loops inside ifs, you're going to have loops inside ifs inside, loops inside functions, and all of these things require indentation. And if you use a single space, it's really hard to see what's indented and what's not. This little program is so simple that, yeah, we can probably get away with it. Some people end up kind of compromising because they think it's cool and they use 2. Okay, don't do that. The standard Python spacing, by the way, is exactly what happens when you press enter in this editor. You get 4 spaces. It's always 4 spaces, okay? That's a standard, by the way. Oh, it's a standard also for this course. So if you'd like to use 1 space or 2 space or even 3 spaces, you can do so, but you will lose a mark on every function that you give me because you're violating the coding guidelines, and I'll just keep circling it. Okay, so get used to it because this is kind of a standard. All right, so here we go. Let's, well, what if we just don't have any indentation at all? And I'll ask you the question, how many lines are inside this loop? Okay, absolutely none. All right, so is there any problem with this? Does it work? Okay, so somebody's claiming a syntax error. Yeah, it's an indentation error because after a while or an if or a def, or there's going to be a couple of others, we'll eventually see some others as well, there is an expectation that the body has to be indented. Okay, all right, so here we go. Let's go and put this back in. Okay, this is what it should look like. Oh, since we're here, okay, just one final thing. Okay, what do you think? Yeah, it actually does work, but it's exactly the same issue that I had before. It's not 4 spaces. So 1 tab, or better yet, as what I tell students is, stop using your mouse when you're programming. The keyboard will fix everything for you. Okay, the keyboard will generally do the right thing. If you don't use the mouse, it will actually improve. So my recommendation anytime that I ever see a student in 1201 using the mouse to move the cursor here, find a different way. Okay, you have cursor keys. You'll notice that I don't do it very often. If you get a really big program, good, it's easy to go down and find something, but generally you'll never see me copy and paste things because you need the skill of being able to type. So do yourself a favor. If you're in this course, it means you're going to have other types of programming course. Get better at typing. Okay, it's not a requirement for the course, but it will help you in everything. All right, so here we go. Now we've got, we figured out the indentation. Okay, everybody knew that from last time. Perfect. I've got a body. I've got exactly 3 lines in a body. Now, I'm going to have to ask a couple of really important but very simple questions. There's nothing weird about these ones. The stuff on line number 1. Okay, I don't know why that keeps appearing every time. Okay, here we go. All right, the code on line 1. When I run this program, how many times does it occur? 1, okay, good. And line number 7? Yeah, always in once, because these things obviously appear before and after the loop. If I put them inside, they might appear multiple times. Now, I can't ask you a question about how many times this stuff inside happened because this is a different type of loop. However, what we're going to do is we're going to terminate this. I'm going to let the thing run all over again, and I'm going to put something in here. All right, first of all, you'll notice that the phrase start of body happens. So remember back in 1101, they probably told you or taught you how to trace programs. We know that line number 1 happened, and then line number 2 happens. Line number 2 is a check to say, is the value not equal to -1? Well, the value right now would have been 0 on the previous line, so therefore I would have gone inside the loop, and as a result I would have said start of loop body. That's why we see it. The very next thing that would have happened would have been line number 4, and of course this is an input, it's waiting for me to type something. So if I type the number 5 and press enter, let's work through what's going to happen. Okay, so right now the program is kind of stuck on line number 4. Okay, because it's waiting for me to press enter. All right, I haven't pressed enter yet, but when I press enter, where am I going to go? Yeah, line number 5. Okay, very good. So if I press enter, what do I expect to see? I better see end of loop body. Okay, good. At the end of the loop body, where do you go? You go back up to the top to the condition and you ask the question, is value not equal to 1? And that condition is true because I just put in 5, and 5 is not equal to 1. So as a result, I'm then going to see line number 3, and then I'm going to see line number 4 again, okay, which will be another input. And that's exactly it. So we see the end of the loop, we see the start of the loop. Of course, the start of the loop happened after I did the comparison. You just, unfortunately, we can't see it. Sometimes I use a debugger to really make it very clear this is what's happening, but I don't have one here. And of course, I'm stuck on line number 4. Okay, very good. And obviously, if I put in different values, I'm going to maybe get different results. But of course, there's one magic value in here, which is the number -1, because that one obviously has something special happening. Okay, now my question is when I press enter, you see, that's going to make this condition right here false. Okay, so my question is, okay, right now, which line is the computer, I'm going to call it stuck on? It's on line number 4. It's not stuck on line number 2. Right now, I'm waiting for input. That's the input statement. So I'm stuck. Okay, the official word is called pending, but that's fine. We'll call it stuck. It's waiting for me to put something in. I'm on line number 4. When I press enter, what's the next thing that's going to happen? What's the very next line? Yeah, it's going to go to number 5, regardless. Well, even though I put a 1, and the answer is yes. I always go to the next line. Well, what about that while? No, you see, this condition is only checked after the loop body is finished. Okay, only after the loop body is finished. So I'm guaranteed I'm going to see end of loop body. That will happen. After line 5 comes line number 2, because you always go back up to check the condition. On line number 2, we'll ask the question, is value not equal to -1? Okay, that's a hard statement to answer. Okay, that condition is now false because it is equal. It's a hard one to say. All right, because the condition on line number 2 is now false, what I'm going to do is now the body is finished and I will go to 7 and I'll print done, and that's exactly what happens. Okay, so just a reminder of the flow. The most important thing here is that even though value changed on line number 4, the rest of the program continued to run. Okay, and even if I did something like this, I won't run it, but even if I did something like this, and I ran it and I typed -1, we're still going to see end of loop, end of loop, end of loop, end of loop, end of loop. It's going to print all of them because you don't just say, this is not just like, okay, whenever this happens, leave the loop. No, the loop is always checked after it has completed everything. Okay? Sometimes students get stuck on this one because you think, okay, well, this is true, but as soon as it becomes false, then I leave. No, it's only false because we check it at the top of the loop each time. Very, very important. So I have to say that one because, as I say, quite often it's a misconception that students get. All right, so here we go. That's one style of loop. What I'm going to do is I'm going to write another style of loop, and we'll actually give it a name this time. All right, I think for this one, I will just go ahead and type it. That's why his caps lock is on. Okay, now I was wondering what that was. I thought it was the foreign character stuff. All right, here we go. I am going to write up a quick little program for a second. Okay. I'll leave it as a comment so we know exactly what we're doing. Ask the user to enter 5 test scores. Okay, there we go. Oh, it's the most boring program. Then stop. It's an incredibly boring program. All right, so let me write up the code first, because you would have seen this pattern already. And then I can try a few different things. Sorry. Input. There we go. All right, and test number. All right, here we go. Here's my first version. Okay, first version of the program. All right, do I have a loop? Yeah. Okay, good. And then we'll have to try a whole pile of things because there's going to be all kinds of issues in here. All right, I have myself a loop. Okay, very good. But I have a special type of a loop. Okay, I think the first thing that I'll do is I'll just run it, and yeah, it should be kind of clear, and we talk about other things. So some test scores, so 70, 87, 68, 90. The program is repeating over and over again, but eventually, after I put in 5 of them, you'll say that it's done. Okay, good. All right, here's what I need to do is, first of all, I'm going to give you a name for this. Okay, and the name is, where did my slide go? Here, pop open the slides, so at least I've got some use for having the slides, because otherwise you'll complain and say, oh, the instructor never used the slides. Okay, so what this is a type of loop called a counted loop. And we know in advance how many times the loop is going to happen. Okay, yeah. How many times did that loop happen? 5, okay, yeah. So and we knew in advance, like ask the user enter 5 scores. Yeah, this is exactly a counted loop. So the number iteration might be fixed or it might be obtained some other way. Okay, I'll have to come up with that for an example. So just pause the second bullet point. It says that I require a counter variable that usually starts from 0. Counter variable. All right. Can you see a variable that I initialized to 0? Yeah, I called it test number. I didn't call it counter because, well, I'm counting tests. Test number 1, test number 2, test number 3, this type of thing up to test number 5. Oh, okay, we'll cover that in a second. And I set it equal to 0. Okay, that's fine. Unfortunately, it doesn't say anything else, and it probably should. Okay, so sorry, I'll make notes to toss in a couple of extra things. A couple of really important things about the counter variable that I used. You'll notice something very important. On line number 5, I did something very, very critical to this program. And I incremented it because what I did is I took the old value of test number and I said put it up by 1. Okay, because remember the very first time that I started with, okay, here we go. All right, this is the variable, easy for me to change. Okay, what's the number right now? 0. No, it's a fist. Oh, no, it won't do that. Okay, here we go. We got a 0, okay? Just complete 0. All right, here's what happens when we come through. Here we go. So we'd hit line number 1. Of course, that doesn't do anything. Line number 2. Here you go. Test number 0. All right, and I'm going to ask the question, is this number less than 5? Yeah, okay, good. So what do? I go into the loop. Okay, now I run the body. I ask for the input. I do something with the input. I ignored it. Okay, well, I mean, that is doing something. All right, but this one right here, this now takes the original value of test, which is currently 0, and it adds 1. So what do I get? 1. Okay, good. And then after line number 5, I jump up to line number 3, and I ask, is this number less than 5? Yeah, okay, good. So I go back in again a second time, and I ask for a second number. Then I add something, okay? And then I go back up to the top, and I ask, is that less than 5? Okay, good. So I back in, person can type in another number, I increment, I still get a 3. I go back up and I ask, is it less than 5? Yes, it is, so I do it another time. How many times have I asked to use it for something? 3 so far. Okay, 3 so far. All right, so we're in here, we ask now, the person types in another number, this now goes up to 4. I ask, it goes up to 4. I ask, is this less than? And yeah, and I've asked for 4 numbers so far. And then finally I enter one final number, it becomes 5, and you'll notice that I don't go any further. And that could be a little counterintuitive. Let me give you an alternative to this. Okay, here we go. You see, the very first number that gets put in is really what I would call test number 1. Some people like to write it this way instead. And it works exactly the same way. So why did I start at 0? Okay, think about a string. What is if you're looking for the very first character in a string, what position is it?
0.
Yeah, that's why people who write programs like to start from 0 because everything starts from 0. Okay, the first thing is number 0. Okay, so you'll see this would work. It will work perfectly fine. The only thing you have to remember, of course, is what about this? This is not going to work because when you put in your test scores, it's only going to ask for 4. Okay, so you have to remember this. Now, I've also seen people do things like this, and I think that's really bad practice. Because somebody who looks at this very quickly, and you ask them how many times does loop go through, they're going to say 6 times. Yeah, so that's not a good idea. That's often another reason why we end up doing this. This one right here. It's a little bit easier to deal with. All right, so, when we're entering the scores, we don't know what test number we're on. Let's fix that. Okay, let's tell the user to enter test score number 1, test score number 2, test score number 3. That would make this a lot nicer of a program. Okay, so yeah, we'll turn it into an F string. You can use F strings wherever you want. And I'm going to stick the word right here, test number score. Okay, so it should tell me the test number I'm about to enter. All right. Oh. Okay, what do you think? Do you like that?
No.
Do you think that's going to be confusing for a user? Yeah, because a normal user who's not a programmer is going to look and go, what, test 0? What does that mean? If he said test 1, everybody understands what that means. It's the first test. Test 0? That's completely weird. So what is somebody going to do? What some people will do is they will say, well, let's just start counting from 1. But now we're back to the same thing. Now we got a less than or equal. It's okay as long as you don't forget. I've got a slightly different way how to deal with this. Okay, there's 2 ways how to deal with it. One's not very good. Okay, sorry? Yeah, okay, here you go. Watch this. Now, I'm going to have to ask a very, very important question here in a second. All right, okay, so what's going to happen is I'm going to take the test number, and although as the programmer I know it's test 0, to the user it's test 1. The next test that goes in, I'm sorry, sometimes this happens. What did I end up doing? There we go. Not sure. Any case, the very next test to the programmer will be test number 1, but to the user it will be test number 2. Yeah, that's fine. You can have something different between the users. So this is test number 1, 45, test number 2, excellent. So we're getting all of the test scores that we want in what I call the user numbering system, and that's pretty good. Now, somebody may look at this and go, you know what? If I'm doing test plus 1 on line 4, I'm going to save myself some time. Because, I mean, obviously, I don't have any need for that. Okay, let's run this. See? Works good so far. Must be fine. I saved myself one line of code. Yeah, this is the thing. Okay, let's put in a test score, 78. When I press enter, well, obviously test number is still less than 5 guaranteed, because once I press enter, what's the value of test number? Yeah, it's 0. Oh, not here, sorry. Type it over to this side. You see, it hasn't changed. When you say test plus 1, that's just doing a calculation. That doesn't say take test and add test number and add 1 to it. That just simply says take the test number plus 1 and display it. Okay, so it's very, very important. A statement like what I've got there in line number 4, the stuff inside the curly braces, that is not modifying. The way how you modify a variable is with an assignment statement. So there's no assignment statement, it doesn't get changed. Okay, unless we do some weird aliasing stuff. So please keep that in mind, because that one is also something that sometimes people end up getting. All right, so there we go. Hopefully, again, this isn't completely crazy or out to lunch. All right, now that, of course, is the world's most boring program ever. Can you imagine this? Okay, suppose you were teaching a class and you had 120 students, and the program said, okay, have the user enter all 120 test scores and then stop. What would be the point? It'd be like you writing a 50-page essay and then deleting it. Okay, yeah, you're probably doing it for some reason. All right, so let's have a reason. Okay, and a very typical one. And then tell the user how many tests were passes. There we go. Now at least we're doing some analysis. Okay, how many tests were A's? How many tests were B's? How many were passed? How many were failed? Okay. All right, so let's put this in. And by the way, if I was given this as a program exercise to say, ask the user enter 5 test scores, tell the user how many tests were passes, I would start and I would write exactly the loop that I just wrote anyway. Does it solve the problem? And the answer is no, but it creates a loop. And it creates a loop that goes exactly 5 times. That's the first piece. In INFSC 1101, you would have learned about a concept called decomposition. They go through a big deal in one of the exercises, and you go and you say, yeah, this is I use problem decomposition, and then we completely ignore it for the rest of the course. I mean, it's true, right? I mean, because I've been involved with 1101 before, and for one of the labs, it was like, yeah, big deal, and then that was it. We never saw a problem decomposition again. You see, what I've done is that statement right up there, that looks like a very typical question that shows up on, say, an 1101 course. Here, we get more complicated things. But it would be like, well, ask the user to enter 5 test scores and count how many passes there were. The decomposition is you first of all ask how many, or ask for the 5 tests. Don't worry about counting them. Don't worry about passes. Don't worry about anything else. Just get the loop to work. And you're going to see me do this a lot. And this is the thing that I think that you end up getting from this lecture more so than me going through slides is, what's my thought process for solving the problem? And this type of problem, the first thing I would do is I would write the loop that I just wrote right there. Okay, that would be the first step. Doesn't solve the problem, but you know what? I'm partway there. Because if you're having problems writing loops, well, you better start with a loop, a simple loop that doesn't do anything. Because if you can't do a loop that doesn't do anything, guess what? You can't write a loop that solves the whole problem. This will happen over and over and over again. All right, here's what I want to do is I don't want to just enter 5 test scores and be done with it. I want to count things. Okay, very, very typical pattern, counting things. Okay, so let's count things. Oh, I've already got a counter. Yeah, but that's counting tests. I need to count how many passes I've got. So what I'm going to do is I'm going to introduce yet another variable. So I'm going to call it the pass. Oh, should I do that? No, because pass means something different. Eventually I'll explain it to you what it is. We'll see it occasionally in the course, but I'm going to have it called a pass count. Okay, here we go, the pass counter. Could we just call it count? Maybe. Could we just call it X? No, that's not a good idea. Count would be the absolute minimum. There's only one thing, but you know what? Pass count I like because maybe we also want a failed count. Maybe we want a total test count. Maybe we got some other things. Maybe got some invalid test counts. All right, so here we go. I'm going to start because, well, I'm going to have 1, which is going to be counting how many tests I've got. I'm going to have a separate variable to count how many passes I've got. All right, well, can we ask to find out whether or not a test is over 60 at this point? And the answer is no. I can't do it until after I've asked for the score. You see, at this point here, I can now start asking questions. If the score was bigger than or equal to 60, I just found something that I'm interested in. I found a test that was a pass. So at this point here, I can now increase it. Okay, we'll run the code. Okay, here we go. Oh, that's pretty boring. Yeah, you have to print it, otherwise it doesn't make any sense. All right, so we better come up with a statement. Let's try to make something like this. There were pass count tests passed. Okay, or whatever the output's required. Okay, so, okay. Is that a pass? Yes. Okay, good, so it should be a 1. Yeah, okay, that's 2. Yeah, it's still 2. 3, yeah, it's right on the edge, and these things you have to check, by the way. All right, and this one right here. 4. Okay, so 4 passes out of all the tests. Oops, not 1201, right? Oh, we can always hope it is going to be. Okay, so let's get you to the point. All right, so this had better tell me 4. If it doesn't tell me 4, then maybe we've got an issue. Okay, that's good. You see, one of the issues that I could have bumped into was this one right here. Yeah, that's called a boundary problem. These, by the way, happen all the time. Sometimes people forget things because, well, remember we had this issue up here. Maybe somebody put a equal to by mistake or left it out. Yeah, you do have to kind of check these things. Okay, but in any case, here we go. That's for counting. You notice what I did is I had a variable that I set equal to 0 before I started the loop, and then inside the loop, every time I found the thing I was looking for, I just added 1 to it. Okay, yeah, that's for counting things. And it happens to fit really well for counted loops. All right, next problem. Okay, how many times does my loop happen right now? 5, okay. What if I have a class with 10 students? Okay, I have to change this. But I don't want to change the program and then run it. I want the program to work for any possible number of classes. Okay, I've got 2 ways how I can solve this. Okay, the first thing that I could do is I could ask for the number of students inside the class. I'm going to call it num students. I'm going to ask right up front, int input, how many students. There we go. And instead of putting the number 5, num students. And you see what I've done? I took something that was very simple. It worked for only 5, and now I've made it more general. Again, we're talking about problem decomposition. These are the processes we go through. You start with something very simple, a very simple loop that works a fixed number of times. We can then solve by counting things, and then we start to make it more and more general. So now, instead of asking the user to enter test scores, instead it's like enter the number of students. Actually, let's do it this way. Let's say ask the user to enter test scores for any number of students in the class and count how many passes there are. All right. In a test, I would make that even more clear. I would say ask the user up front how many there are. Okay, but this is the business case. Okay, and sometimes we don't always say this. This is what we're trying to do. I haven't told you exactly how to do it. In this course, I'm usually very prescriptive, and I say ask the user before you start. Okay, so it would be a little bit of leading. So here we go. How many students? Okay, so give me a number to try. 6. Okay, that's a good number. A bad number would have been if somebody said 600. Okay, so here we go. 1, 2, 3, 4, 5, 6. What should happen the very next time I press enter is this program should be done. And what number should it say? 3 passes. Okay, good. Okay, excellent. All right, so there you go. There's a slight improvement. Yeah.
Question that's
Sure.
if you remove the hashtag in line 2, can it work?
Oh, and remove the hashtag in line 2. No, at that point, you'll have a whole pile of problems because, well, this will now be treated as code. And the first thing it will do is it will look and it'll say, there's no variable called students. Okay, here, I can even give that one a shot. There you go. It's a syntax error. Oh, actually, it's weird because it starts off and it says students in the class, and it actually complained about the word class. Yeah, well, that's because the word in, class, and all mean something in Python. Yeah, you've seen the word and. You haven't seen the word class. I don't know if you've seen the word in or not, but as substrings, you might have seen this. And what it's doing is it's just trying its best. But no, I put the hashtag because I wanted this to be a comment because I want the compiler to, or sorry, the interpreter to completely ignore it. All right, and of course, okay. Okay, who would like to come and enter the 9,000 numbers for me? Okay, would it work? Okay, do we know for sure? Okay, it's a small enough program. Yeah, if we've tried for small numbers of things, it would probably work. Oh, hey, cool. What if I said 0? Does it still work? Is it still consistent? Let's see. Well, that's true. Yeah. Yeah, that is true. It is something to point out because every program often has these very weird kind of what I describe as boundary conditions, and in the weird cases, like the empty cases, maybe you have to do something special. Okay, all right, so here we go. That's one. I'm going to do the same program, but I'm going to change it up a little bit. Okay, this, by the way, is also a counted loop. I've got a loop counter, and yeah, we know in advance before we started the loop how many times we're going to go through. I can't tell you right now because it depends on the person, whatever he types, but it's exactly the same pattern. It's a counted loop. Notice that I initialized the counter to 0 before I entered. At the very bottom of the loop, not halfway through, not at the top, at the very bottom, I did the increment. Okay, why do I always put it at the bottom? To remind myself that not to forget, because what's going to happen is when you get a big program, you're going to forget. And if you're missing the increment, you can look at that and go, oh, yeah, you're missing the increment. That's why you're getting an infinite loop. Okay. Okay, so here we go. How many students? 5. All right, and this is known as an infinite loop. It'll never possibly stop. The only way you can stop it is hit terminate. Okay, all right, let me do a slight difference, okay? And I think you have seen this in your other course as well, but just in case you haven't, we're going to do it here anyway. Oh, what did I call it? I called it the score last time. Oh, my numbers, I'll put the number in afterwards. That's a different problem, right? Get something simple to work first, then worry about the complicated stuff later. We saw this a few minutes ago, okay? Almost exactly the same thing. Okay, there we go. It's a really simple, small loop. It's like, okay, well, let's take a look. All right, enter a test score. Okay. How many times is this loop going to go? Okay, it's going to continue until I have to enter a -1. Okay, very good. This is a different style of loop. Here you go. Here's a name for it in case you haven't seen it. It's called a sentinel value loop. What we're doing in this case is we're saying, okay, just let the input happen over and over and over again until somebody enters some magic value. In this case, the magic value is -1, because I'm assuming that -1 is not actually a valid test score. Is it? You're hoping it isn't, right? So, because otherwise, no. Don't worry, it's not valid. Valid test score is between 0 and 100. Okay, so here we go. What can we do? Well, we're supposed to be counting how many passes there are. Okay, well, let's go back and do it again. Okay, so exactly the same thing. What do we have? Well, we have a pass count. And what did I initialize pass count to before? 0. All right, and in here, take a look at this. What I'm going to do is I'm going to put my check right here, and we can talk about why it went here. I'm going to say if it's bigger or equal to 60, I'm going to say that the pass count goes up by 1. And I'm going to set the same thing. There were. Okay, I'm going to be tired of this pretty soon. Pass count. Okay, there we go. Yeah, eventually I get tired of doing this, and I'll put ridiculous print statements because the exact output, obviously, it doesn't matter. All right, so here we go. I took that thing that I showed you a few seconds ago that worked until I put a -1, and, well, let's just go ahead and run it for a second. Okay, so here we go. 80, okay, 90, 40, 60, 20, and I'm going to ask, how many of those were passes? 3, okay. Okay, of course, I have to press enter, but it's not going to stop yet because the program is being set up to keep going until somebody presses a -1. Okay, at this point right here, yeah, there were 3. And of course, fill out the ... with the rest of the message. Okay, a couple of things about what I've just done here. I've done this very much on purpose, and again, this is supposed to be a review of the 1101, so I hope you've seen this already. But notice something that I did. I did something really, really strange. I put an input statement just before the loop, and I put another input statement inside the loop but at the very bottom. Okay, why did I do it this way? How come I didn't put it somewhere else? Okay, we'll get to that in a second. Okay, we'll try it. But take a look at this. I'm going to ask the question. If you're on line number 5 waiting for input and you press enter, what's the very next line after line number 5? 6. Okay, good. If you're on this line right here, line number 9, you're waiting for an input, somebody enters something and presses enter, what's the very next line? Yeah, and line number 6, exactly the same. Okay, yeah, so in other words, it happens just before. It happens just before you check the condition. Okay, there you go. And this is a very, very typical thing. Sentinel-based loops often look like this, although I'm going to give you another way out here in a few seconds. And you might say, well, what if I just go the other way and put it right here where I only have to have 1? Good. Some people have bumped into this already. If I try to run this program, we're going to have an issue. Take a look. Line number 5, it says that score is not defined. Remember the way how the program works. Line number 1, 2, 3 happens. Okay, nothing happens. They're boring. Line number 4 happens. That initializes pass. Pass count to be 0. And then on line number 5, I ask, okay, is score not equal to -1? Well, sorry, we don't even have a variable called score. All right, so we say something like this. Somebody will come up with this almost always, and they'll say, well, just make it equal to something. Okay, because now we can get through. Okay, yeah, that's fine. Does it work anymore? Okay, because somebody will say, yeah, but you know what? I can just check this. Okay. How many of those are passes? I think I see 4. The 80, the 90, the 60, and the 100. All right, so if I press enter 1, you see, I have no idea what I'm talking about. I didn't need to do that. Yeah, in this particular case. Let me change the program just a little tiny bit. Okay, let me get rid of the comment because now the comment will be weird. Okay, I want to see how many fails there were. So I'm going to have a fail count. Okay, well, here we go. The fail count has to go here, the fail count has to go here, and what do I have to do to this condition? Yeah, under 60. That's a fail count. Okay, good. Let's run it. All right, so here we go. All right, how many of those are fails?
0.
0, very good. But my program says there's 1. Yeah, because take a look what happens. You see, I was stuck on line number 5. Okay, it was pending. The person typed in -1, and the first thing that I did was I said, if the score is less than 60, increase the fail count. I shouldn't have counted that. Okay, by doing what I did before, which was ask before, ask at the end, and don't try to be smart and initialize it, this will be perfectly fine. So here we go. Here's a 90, 90, 90, and a -1, and it still says 0, because now it's not considered because I don't do this check. And that's why you'll often see this pattern where you'll see the input just before the insert, just at the very last thing. Okay, so standard programming pattern. Okay, let's see what else I've got here in the next line. Loop flow interrupters. Okay, excellent. So this might be something new. Okay, this might be something new. This is kind of a more flexible program, by the way, isn't it? Because this way you can ask the user to keep entering until they basically had enough. That's the way how most programs actually work. Because you want to keep using it until you basically shut it down. I mean, think about the program like, Microsoft Word. If you're going to use this, I mean, how many pages or how many characters are you going to type? I don't know. I'm going to keep going until I've had enough. Yeah, that's basically a Sentinel-based loop. It's the same idea. How many test scores you can put in? I don't know. I'm going to type them all in. When I'm finished, I'll press -1, then it can do my analysis. How many pass? How many fails? What's the average? Oh, average? Okay. I think it shows up here in a little bit. All right. Obviously, this is more flexible. Okay, the first version of the program was kind of, oh, sorry about that. Got the wrong thing put here. Okay, just so I don't forget what I'm doing. All right, let's write another version of the program. Same idea. Keep asking until the person types -1. Okay, so, okay, fail count seemed to have a problem. Okay, so here we go. Fail count is equal to 0. While, okay, you're going to see me do this an awful lot of times. I'm going to put, I don't know, I'll figure that out in a second. All right, and I'm going to put a score, and I'm going to say int input, and we're going to say enter test score. Oh, I forgot to put counters on the other one. Can you have them as well? And the answer is yeah, you could. We're going to put an if score is less than 60. I'm going to say that the fail count goes up by 1. Outside at the very end, yes, I'm going to do a print statement. I guess I didn't have to erase everything. Print f string and okay, yeah, that's so you can see that I'm already tired of typing output statements. All right, that didn't take long. Okay, about 4 lectures and I'm finished. This is how my outputs often look. All right, so here we go. So obviously this is going to go through, and the idea is that any time that you have something less than 60, it's going to count. Okay, but the issue is, well, how do I stop this loop? Okay, what do I put up here? Well, I'm going to introduce something completely weird and absolutely crazy. I don't know whether or not you've seen this before, but we've got a magic word in here called true. Okay, now remember how the while loop works. Okay, I would run line number 1. Okay, not a problem. I'd come down here and I would ask the question, is that true? Yeah, of course it is. All right, and so therefore I'm going to come inside here and I'm basically going to ask for a test score. I'm going to increase the fail count if it's lower. And at the end of this if statement, at the end of this loop, I'm going to come back and I'm going to ask, is that true? And yeah, that still is true. All right, and I'm going to ask the question, when is true not true? It never is, okay? It will never, ever, ever, so in other words, I just generated an infinite loop. We're not supposed to do these things. So bad programmer. All right, I'm going to show you something. Okay, somebody from another okay, I'm not making fun of any of our other lectures, but if I showed this to 1,000 CS people and I said, hey, look what I'm doing, they would go, no, you can't show the students this because it's bad. But actually, I think it's completely legit. It's a completely legit way of writing programs. The reason why people don't like it is because, I'm going to call it the old days of programming, we wouldn't have the ability to get out of a loop like this ever. Okay, well, right now the only thing I can do is stop, but we actually have something really, really important. Okay, and I've got access to a couple of very, very useful terms. And again, I don't know whether or not they're covered in infs 1101. But remember, you see, if score is equal to -1, that is something very important. Okay? Because really what I want is, I want to stop. That's what I want. I want to stop and I want to show the rest of this. But I don't want to stop the entire program. I want to get out of this loop. Because if I can get out of this loop at this point right here, and I can get down to line number 10, I can print my result, and there's not any of this kind of weird type of thing. And yes, we've got a term for it. It's called break. Okay, so I don't know if those are still covered or if those are covered at all in 1101. Doesn't matter, it's something new, at least I'll consider it new. And what the word break does, break stops the loop right now, does not go any further. Okay, no further. What I'm going to do is, let me print one message right here. Let me put my variables back as they should be. All right, here we go. Bottom of loop body, so that we know that we got there. Okay, it's not required for the program, but maybe for understanding. All right, so I'm inside my infinite loop. We'll never get out. All right, if I type a number like 70, okay, it's not equal to -1, so the break won't happen. We will check to see if it's a pass or a fail. It isn't, but we will see the bottom of the loop body, and then of course it comes back up again. Okay, if I put in a 40, it's going to do exactly the same thing, except the fail count will go up by 1. Okay, and I'll make another failure. There you go. So now I've got 2 of them. But right here, this is the interesting one. All right, remember, I'm currently on line number 3. When I press enter, where are we going to go? The line number 4. Okay, we're going to ask the question, is score equal to -1? It's going to be true. So therefore, I'm going to do line number 5. Line number 5 says, break out of the loop. Get out. Okay, so immediately go just after the loop, which of course happens to be line number 11. That's the logic that happens here. So there you go. So now I've broken myself out of the loop. You'll notice that the bottom of the loop didn't happen. The condition doesn't happen either. Okay, it's just you're finished. Okay, what do you think? I mean, if you're looking to put together one of these loops that stops when somebody enters a -1, I think a lot of people look at this and go, you know what, that makes more sense than having an input just before and an input right at the bottom. Okay, older languages, you might not be able to do it, but because we have a break in this language, I think it's completely reasonable. But some people are very, very, I'm going to call them theoretical and pure, and they say, no, you can't do this. Loops have one way in and one way out only. Okay, but in reality, yeah, there's many ways out. If you would like to structure any code this way, just double check with your lab instructor. If you're in my section, I'm going to say, yeah, I don't care. This is fine. I don't have any issues with it, but just if I'm not your lab instructor, just double check with them before you say, yeah, the lecture section did this. You have to follow whatever they're asking for. It is actually incredibly useful. Let me make the program a little bit more interesting. Okay, and that will fit this one right here. And just give me 1 second while I see how many more. Wow, I'm running out of time. It's already 3 o'clock. Sorry, I don't go super long too often, but today it might be 1/4 after. Okay, I'll stop. I know I won't finish everything. Anything I don't finish, I'll pick up at the beginning of next class, okay? So sorry, it might be a little bit longer. All right, here we go. Oh, not that one. All right. Oh. Remember what that was? That's a multi-line string. I frequently use them for long comments, so I don't have to keep hitting hashtag. Okay, so just letting you know what I'm doing. Okay, so here's what we're going to do. We're going to write a program that asks to enter multiple test scores until the user enters -1. Do we have that so far? Yeah, good. When the program is done, display the number of tests in total and the number of failures. Okay? Okay. If a user enters a number that is outside of the here we go, valid score range, ignore the input. There we go. Now I've got a whole pile of stuff. All right, I won't solve all of it at once. Iterative solution. All right, so I got some stuff right here. I've got fail countings. Okay, that is required. I also need to know how many tests I have in total. Okay, because I don't know in advance. It's not like the other one where I ask the user how many tests do you have. Not only do I need a fail count, I'm going to need to have, well, I'm going to call it a test count, and I know that there's multiple ways of doing this. Okay, so here we go. Test count is equal to 0 because that's how many I have. All right, you see, what I'm going to do for right now, I'm going to check if it's a -1. Okay, that's fine. We know to get out. And obviously we know that every time that we ask for an input, I have to put this up by 1. Okay, so fails. All right, here we go, and print total tests. Okay, then test count, just so you know what's going on. Okay, we can obviously do multiple things. All right, so what do you think about this? Here, let's give it a shot first, so I don't even have to ask any questions. Okay. All right, there we go. We already know the -1 is going to work because I already built a loop for it. Remember I said decomposition, write a loop first, even if it doesn't work, it doesn't solve the whole problem. Build on top of what you've got. All right, when I press enter right here, how many tests should it say? I didn't ask what it will say. How many should it say? It should say 4. It should say how many fails? 2, okay. Of course, when you run it, it says there's 5 tests. Why does it say there's 5 tests? Because I incremented the test count before checking to see whether or not it was a -1. Okay, so that's fine. Obviously, what I need to do with this is I can't do this before, but if I do it afterwards, I think we'll be much better shape. So here we go. 70, 60, 30, and 20. Okay, again, I'm expecting 4 and 2. Oh, sorry, and a -1. So 4 and 2. So now it's working. Okay, next problem. 80. 100, 130, -45, 60, and when I type -1, how many test scores have I entered? 5. Oh, yeah, but remember what I'm supposed to do. If I enter a test that's outside the valid range, which obviously that 130 and the -45 is, how many test scores should have I actually been counting? There should have been, okay, I got an 80, I got 100, and I got a 60. 3. How many fails? Yeah, there should be none, right? Because the 45 should be ignored. The -1 should also be ignored. So it should say 3 and 0, but instead it comes up with 5 and 1. All right, so why 5? Well, it's because every time, if it's not a -1, I'm counting it. Yep.
We're supposed to put another condition.
There you go. So it's another condition to solve. Okay, yeah, we'll do that in a second. Why does it say 1 fail? Well, the 45, the -45 is causing a failure, right? Because the only thing we're checking here is this. Now, somebody may say, well, what if we just ask us less than 0 and break? Okay, but that's not exactly the problem because I'm going to allow people to enter a -45 by accident. I just don't want to count it. Okay, so it's exactly it. So somebody just said, well, we have an extra condition. All right. You see, the condition is like this. You see, if the score is less than 0 at this point, or the score is bigger than 100, should I count it? And the answer is no, I shouldn't count it. In fact, I shouldn't look to see if it's less than 60, bigger than 60, or anything else. So I'm going to introduce a second new loop interrupter, and it's called a continue. Okay, so a continue is kind of like a break. It interrupts the regular flow of the loop, but instead of stopping the loop completely, it says go back up to the top and do it again. Skip the rest of it. Okay, so in other words, there is no bottom of the loop when this happens. It just continues on. In fact, what I could do is I could print a message. I could print a really polite message like the number you entered is not within the valid range. Okay, we'll just do this. Okay? Yeah, all right, so here we go. So we put in a valid number. Okay, which line number am I on? Because we have to work this out. Right now, the program is blocked on line number 12. Okay, so if I go and I enter value 80, here's what's going to happen. It's going to go to line number 13, but that's not true. I'm going to check and find out if the score is outside of the available range. That's not true. So I'm going to add it as a test count. I'm going to find out if it's failed. I'm going to see the bottom of the loop. That's the happy case. Okay, bottom of loop. All right, I'm not going to demonstrate -1 because my whole program is finished. I think what I'm probably more interested in is something that's valid. So 30, it will be exactly the same, except line number 22 will happen. Okay, there we go. Now, let's put in 123. This is the more interesting one. All right, so I'm on line number 12. After line number 12 comes line number 13. When I press enter and scores 123, is it equal to -1? No. Okay, so what I do is I come down here and I ask, is this condition true now? Yes. And yes, it is. So what do? It says, stop it. Okay, and it does continue. A continue says go to the top of the loop, but let the loop continue to run. Okay, so the bottom of the loop never is reached. Okay, it's another interrupter, but instead of stopping the loop completely, it says go back up to the top. So what will happen is, yeah, it will say stop that, but it asks again. But notice that the test count didn't go up. Okay, the test count did not go up because that was skipped, because I went from line number 18 back up to line number 11. If it had been a negative value, like -900, it would do exactly the same thing. It would never trigger the if condition on line number 21 because it's being stopped by line 18. If I finally put a -1 here, how many tests did I enter? How many valid tests did I enter? 2 tests. How many valid tests were fails? 1. So I better see 2 and 1, and that's exactly what I see. Okay, cool, right? All right, so maybe with some luck, that was something new. Okay, 308. Okay, I've already done the infinite loop. Okay, an example of an infinite loop, that's fine. Ooh, summation pattern. Okay, let me see. Find the maximum input validation pattern. All right, here's what I'm going to do, because I know I'm running short on time. I always promise I'd be finished by about now. I'm just going to show you 2 slides, and I'm going to say go and read them for next time. You don't have to, but let's pretend you're going to go and listen to them. All right, and what I will do at the beginning of next class, I will take like 5 minutes to do these 2 because I think they're important patterns. All right, one of the patterns that we will end up seeing quite often is to have to go through and add things up. It's called an accumulator pattern, summation pattern. The way how it works is we have an accumulator and we keep adding things up. I know that this was covered in 1101. Just go back and review it for a couple of seconds before our next class. The other one, which I will come back, this one looks more complicated. It's for finding the biggest or the smallest, and I will explain this. I know that I need like 15, 20 minutes to do both of these slides well. And I don't want to take the chances because I can already see people are like, I want to go, I have had enough. My brain is full. That's completely understandable. Okay? All right, so these 2 I will do at the beginning of next class, and hopefully we have enough time. Okay? All right, so we're done for today. Now you can go.
Thank you.